This is paper 2, section 2. So in the next few minutes, I want to explain to you in a way that you'll understand on how to tackle almost any question that comes from geometric progression and arithmetic progression, such that when you find a question from AP and GP, you'll never ever again get to panic, but you'll always be so happy because you'll be knowing that you have some 10 free marks in that question. So let's get to this particular question that will give us exposure to AP and GP concepts. So we have it as follows. We are told that the first three consecutive terms of a geometric progression are 3 to power 2x plus 1, 9 to power x, and 81 respectively. And then part 1 tells us calculate the value of x. We have part B, and also I believe we will also have part C and part D, so that this question can culminate to 10 marks. But let's start from where we are, and that is calculate the value of x. This is quite a wonderful question that is testing on different concepts and your understanding on AP and GP. So the pattern that we have here, we have the terms as follows. We have 3 to power 2x plus 1. The term that follows is 9 to power x, and finally 81. So there is one particular thing that is being tested over here, and that is if you know how the sequence gets to relate in a geometric progression. And this is how the terms gets to relate. You see, when you pick any consecutive term, let's say 9 to power x, and then you divide by the term that appeared previous, that should give you the common ratio of these terms. Same case, once you divide 81 with 9 to power x, it should give you the same result with 9 to power x divided by 3 to power 2x plus 1. Well, saying that might sound a bit complicated, but once we write it down, it becomes a bit so much easy. And let's go ahead and do that. So what we have is 9 to power x. Let's write it down here. 9 to power x. So once we divide that with 3 to power 2x plus 1 at the power side, that one should be equivalent to 81, what we have here, divided by 9 to power x. So what we have simply done is getting to divide this value with this value, and we say that that one is equivalent to this value divided by this value. You know, this is like having a sequence where, let's pick any case. Let's assume even the numbers are starting from 4, and these numbers are multiplying by 2. So the sequence that would follow after 4 is 8 and then 16. You see, with these numbers, it will be true to say that 8 divided by 4 is equivalent to 16 divided by 8. Why? Because this one is going to give you a 2, and also this one is going to give you a 2, provided that you are dividing the values that follow each other. Immediately they follow each other, that is from the right to the left, and that is exactly what you've done here. So the next thing that you are going to do is that we are going to find a way of getting to simplify these numbers so that we can be able to find a point where we can be able to get the value of x. And let's go ahead and do that. And I believe this will be pretty much interesting and easy, because now here it's also testing some concepts of indices, because we are now supposed to convert this one to the simplest base power, and that is 9. We know that 9 is equivalent to 3 to power 2. And here the power is x, therefore we multiply 2 by x, we get 3 to power 2x. We go to the other case, we have this one. This is a bit so amazing because it's reminding us on some concepts about indices, and that is 3 to power 2x plus 1. This one is equivalent to 3 to power 2x multiplied by 3 to power 1. I hope that you do know why, because this is the addition multiplication law of indices, where if we have multiplication sign between common bases, that is 3, we always add the power. So this is a reverse of that law. So always know that 3 to the power 2x plus 1 is equivalent to 3 to the power 2x multiplied by 3 to the power 1. So this one is equivalent to, we have 81. 81, we can convert it to the simplest base to get 3 to the power 4. And then we have 9 to the power x. We convert it to the simplest base, we get 3 to the power 2x, like that. You see how juicy it is, because it's something that is a bit interesting, because you see this is 3 to the power 2x. We can divide by 3 to the power 2x there, divide by 3 to the power 2x, we get a 1. So therefore, at the numerator here, we remain with 1 over. At the denominator, we remain with 1 over 3. It's becoming a bit more interesting and much easier. Here, what we remain with is 3 to the power 4. And what will remain here is 3 to the power 2x, nothing much, we can be able to do that. So with this, we can do some cross multiplication. So we have 1 multiplied by 3 to the power 2x. That doesn't change 3 to the power 2x, therefore it's going to remain like that. But here we have 3 to the power 4 multiplied by 3. So this is 3 to the power 4 multiplied by 3. When it's just simply 3, that we are multiplying with is equivalent to just 3 to the power 1 is equivalent to 3. So what we have here, we can't do much about it, therefore it's 3 to the power 2x. What we have here is that we add the powers, that is 4 plus 1. That's gonna give us a 5, yeah, true. So finally, since the bases are equal, we can equate the powers to have 2x is equals to 5, like that. Finally, we divide by 2, and we get the value of x as 5 divided by 2. We can put it in decimal form to get 2.5. And what does part A requires us to do? It actually requires to calculate the value of x, and we've been able to do that. And by just simply doing just that, you just get your full 3 marks, like that. So let's move on to the second part of it. And actually, this will help us to revise a bit almost everything about geometric progression, and also hope that there's something to do with arithmetic progression, but we'll get to that in a short while. For now, let's get to part B. Part B is telling us find the common ratio of the series. So what we do to be able to get the common ratio of the series is that we pick up the values that we have. We have our values are 3 to the power 2x plus 1, and then 9 to the power x, and then 81. And since that we have already the value of x, we can be able to convert this one into real values by doing the substitution. So here what we are going to get is 3, and then we have 2 multiplied by 2.5 plus 1. And here, 9 is equivalent to 3 to the power 2. And then it is multiplied by x, and x is 2.5. And finally here, 81, that's already a number without any variable or constant. So finally what we do here is that we complete the simplifying part. Therefore we are going to get 3, and then we have 2 multiplied by 2 to 2.5, that is going to give us a 5. 5 plus 1, that's going to give us a 6. And here we have 3 to power something. This is 3 to power 2.5 multiplied by 2. That's going to give us a 5. And here what we have is simply 81. You see 81 is equivalent to 3 to power 4. We can just convert it to a power form so that they are a bit uniform. So finally, to get the common ratio, what we are really going to do is that we pick any consecutive numbers from right to left, and then we divide. So we can pick 3 to power 5 divided by 3 to power 6. Here we apply the law of indices, that is, we minus the powers, that is 5 minus 6, that is going to give us 3 to power 5 minus 6, that's negative 1, and 3 to power negative 1, that one is equivalent to 1 over 3. Actually, you can try it out to do 3 to power 4 divided by 3 to power 5 to find out if you are going to get 1 over 3. And actually, you should be able to get 1 over 3 because they are following each other sequentially in this sequence. As long as you pick the immediate number that is on the right, you divide with the number that is on the left as they get to follow each other. But that is it to find the common ratio. That is what you do for geometric progression. And notice it's important to differentiate between geometric progression and arithmetic progression. Yeah, because if it was anything to do with AP, what we usually do is that we always minus the numbers. We minus the number that is on the left from the one that is on the right. So we do the number on the right minus the number that is on the left. That is if that was an AP. For now, let's keep moving on with the remaining few parts. We are told, wow, this is so wonderful. We are told calculate the sum of the first 10 terms of this series. You see, the questions that are usually tested over here are usually maybe to find a certain value that has been left out, to find the common ratio, maybe to find the first term, and also to find a certain term. You can be told find the seventh term, find the fifth term, and so on. And also there's also a possibility of now being told to find the sum of some terms in that sequence. Therefore, it's important that you do really understand how you are really supposed to find the sum. And this is exactly how you are really supposed to go about that. So to calculate the sum, we usually use this formula. That is, you see, we've already calculated the common ratio, and you're going to notice that this common ratio, it is less than 1 because it is a fraction that is less than 1. Therefore, the formula that you're going to use to calculate the sum of the first 10 terms is that we usually take the first term, which we call A, and then we multiply that with 1 minus the common ratio to power n, and now here n is representing the terms that we have been told, and then we divide all that with 1 minus the common ratio that we got. So the most important thing here is to really understand and master this formula, because that is what you are going to use. But if this ratio was more than 1, what we could have done is that we could have started with r to power n minus 1, and here at the denominator we could have used r minus 1. But because this ratio is less than 1, that is why we have the formula as 1 minus r to power n divided by 1 minus r. Therefore, it's important that you get to distinguish between the two, because you never know the kind of question that you are going to get. Yeah, for just in case you get a question that is asking you to find the sum of terms where the common ratio is greater than 1, you know which formula to use. But for now, this is the formula that you're supposed to use, and let's go ahead and apply it and see what you're really going to get. So, do we have the first term already? Yeah, we have it already here with us, and that is 3 to power x. We can actually convert it into its real number without the power form, and that is 729. So we have that into brackets, 1 minus r. What is our r? Our r is 1 over 3, and that is to power n. And what is n? For our case is 10. Wow, this is likely to form a huge number, but that makes it even more interesting. So here we have 1 minus r, so that is 1 minus 1 over 3. Yeah, this is quite manageable. So what you're going to get here is 729, and then we have 1 minus 1 over 3 to power 10. What is 3 to power 10 actually? That's a huge number. That is 1 over 59,049. Yeah, at this case, when you use your calculator, there is no harm with that, and you'll not be penalized for that. 1 minus 1 over 3, that's 2 over 3. That was pretty straightforward. So for this one, so we have 1 divided by all these. So we do 1 minus this number, and that is going to give you something to do with 0.99998 and then you can go ahead and divide by 2 over 3 directly. See what you're really going to get. And then finally we'll multiply that with 729. So finally what you are going to get once we work out this, it's 1093 13 over 27, like that. Yeah, this was actually so much expected, because you see, if you look at this sequence carefully, they are reducing, but as they reduce, there is a point that they'll get to be fractions, because you see this is 3 to power 6, 3 to power 5, 3 to power 4. So that implies that the next one will be 3 to power 3. This is the first, second, third, fourth, fifth, 1, 2, 3, 4, 5, 6, 7, 8, 9. So actually, this is really interesting. If you get some time, that is, if you get some time, just try to add 3 to power 6, 3 to power 5, 3 to power 4, 3 to power 3, 3 to power 2, 3, add to 1 over 3, add to 1 over 9, add to 1 over 27. It should actually give you this value. You can confirm that later on. And that actually even makes the work of numbers to be even much interesting. Yeah, but this is not the method that you're supposed to use it in an exam. The one that you're really supposed to use is this one that we've used of the formula. Yeah, this is just for making maths and numbers a bit more fun, and also to help you confirm whether you are going to get a similar case to this one. Yeah, which I believe that's the case that you should get. So let's proceed on with the last part. The last part tells us, or rather reads as follows: given that the fifth and the seventh, it's important to notice, fifth and the seventh terms of this geometric progression form the first two consecutive terms of an AP sequence, calculate the sum of the first 20 terms of the arithmetic sequence. Wow, and actually this is what makes this question to be wonderful, because as we also revise the geometric progression, we are also doing some part of AP, and this will actually make it to be so much comprehensive. So the fifth and the seventh term of this GP. So the first thing that we find out is the fifth term. But to be able to get the fifth term, we must know how do we get the nth term, or how do we get any term from a GP. So how we are able to get any term from GP is that we usually take the first term and then we multiply that with the common ratio to power n minus 1. I think once we do it practically, it will become a bit easier. So that would imply that the fifth term should be equivalent to A. And what is our A? We can actually go ahead and apply it directly because we already know these values. Do you know the first term? Yeah, the first term over here was given the fifth term and the seventh term of GP. So what is A, the first term of GP? The first term of GP, we have it right here, this one, which was 729. That is 3 to the power 6. So that's what we use here, 729. Okay, we are multiplying that with R. And what is R? 1 over 3. And what is N? For this case, N is 5. Therefore, we do 5 minus 1. That's going to give us a 4. So we are doing 1 over 3 to the power 4. You know, 1 over 3 to the power 4, that should give you 1 over 81. So 181 over 81, we multiply by 729, and that is going to give us a 9. And that is going to give us a 9. And actually, I'll show you something interesting over here in a minute. So this is the seventh term. We go to the seventh term. Seventh term, we pick the first term, which is 729. We multiply by the common ratio, which is 1 over 3 to power. Here, our n for this case is 7. Therefore, we do 7 minus 1 to get a 6 there. So, using your calculator, you can do 1 over 3 to power 6. You see, this is like 1 over 729 because 3 to power 6 is 729. So 729 multiplied by 1 over 729 is going to give you a 1. Like that, it's going to give you a 1. So I think we don't need the upper part again, so we can have our focus now on these final parts, because I think we have all the elements already. So we are told that these fifth and seventh term of this GP form the first two consecutive terms of an AP. So we are now dealing with now AP. And here is now where the difference comes in. So for the AP, we have the first term being 9 and the term that follows being 1. So with this, we can be able to get the common ratio for the two. But for this one, we call it the common difference, because for AP, what we are dealing with is usually the difference but not a ratio. For ratio, we use it when we are dealing with now the geometric progression. So to get the common difference, what we do is that we pick the number on the right, which is 1, and then we minus 9, and that is going to give us negative 8. So actually, if you wanted to really continue with this pattern, just to add you some more information, what you should do is to keep on adding this negative 8, you add to 1, and then you get the value here. Negative 8 plus 1, what's really that supposed to give you? It's supposed to give you negative 7, yeah. You can add negative 8 to negative 7. That's gonna give you negative 15. So this is how that pattern looks like. But that's not what the question requires us to do. The question requires us to find the sum of the first 20 terms. But for us to be able to find the sum of the first 20 terms, we should be able to find the sum of any terms. And the way that we find the sum of any terms, we usually take n over 2, and then we multiply by 2a plus n minus 1 multiplied by the common difference, like that. For this case, we are finding the sum of 20 terms. Therefore, our n is 20. Therefore, we are going to have a 20 there, divided by 2. And then this is multiplied by 2, multiplied by a. A is the first term. What's the first term here? That's 9. And then we have plus n minus 1. What's our n is 20. Therefore, we have 20 minus 1 multiplied by the common difference. What's the common difference? We got it already here. That's -8. Okay, let's go ahead and simplify this. 20 divided by 2, that's 10. 9 times 2, that's 18. And then we have plus 20 minus 1, that's 19, multiplied by -8, like that. So finally we have 10 and then 18. Definitely here we are going to get a minus something. Therefore it's 19 multiplied by 8. That's going to give you -152. Yeah, that's true. And then, so that's 10 multiplied by 18 minus 152. That's -134. Once we multiply that by 10, we get -1340, like that. And actually, that's the sum for those terms. And I really hope that you do really understand why we are getting a negative. It's because, you see, these terms are decreasing. Therefore, we will have a lot of negative numbers that we are adding together, which then will make the sum to be negative number. And that is why we are having this as a negative. Also, there's something that I had told you that I'm going to show you. You see this one. What we did here is that we calculated the fifth term using our formula here, and we got a 9. And actually, if you go to our rough work over here, we said that this is the first term through the manual calculation. This is the second term. This is the third term. This is the fourth term. And this is the fifth term. And you see this is 3 to the power 2. Therefore, 3 to the power 2, which is 9, becomes our ninth term over here. You see, whichever way that you use, you should always be able to get the same answer. And that is the good thing with numbers and with mathematics. So even as you do these kind of questions, you can always be able to mark for yourself and be able to tell whether you got it right. And also, as you use different methods, you are able to confirm to yourself that you didn't make an error. Because any moment that you work out with different ways or methods and then you get different answers, then that would imply that somewhere you may have made a mistake. But that was it for the AP and GP. So it's important that you get to understand the formulas for calculating the sum for AP, for GP, because that is what is commonly tested, how to find the common ratio and common difference for each, and also how to calculate any given term while you have been given some information about the sequence. Once you master those things, then I believe you should always be able to get any question that is coming from AP and GP. So I'll keep uploading more tutorials and more valuable practice questions so that you can continue empowering yourself in numbers and improving your mathematics ability together with elevating your creativity when it comes to numbers. This is Countacy Mathematics, where we continue to make mathematics fun and enjoyable.